Hi, welcome to an NX 12 video tutorial. I did this crankshaft in almost all programs and in different ways. Today I want to show you the potential of the pattern feature in NX 10, 11 or 12, which allows it to do this very quick. So let's have fun with NX 12. Okay, let's start with a sketch on that plane. Confirm. I need two circles. One has a diameter of 80. One has a diameter of 300. They should be aligned. Yeah. So I think this didn't quite align, so now they're aligned, and this point should be aligned with the sketch origin as well. Okay, the distance from this one to that one should be 167. Okay, and that distance from this point, no, not from this point, but from that point to the sketch origin should be 35. And then I need the profile tool. This should look maybe like this. Okay, this should be tangent, this should be tangent as well. Let's trim. This should be trimmed, that, this one, that one, this one, that one. Now the distance should be 150. Really? Let's try to move this up. Yeah. And that angle should be 40. And it should be symmetric. So let's go for symmetry. Make symmetric this line, that line, that's the symmetry, and take note, that's a very strong symmetry. Okay, finish that sketch, and in this case I want to do my expressions before I do any modeling. So go for expressions, and I got 3 expressions. One is the counterweight width with 20 millimeters. Then the crankpin channels width. Oh, that's wrong. Spelled it wrong. So it should be DTH. Is 40, and the main channels width should be 40 as well. Confirm. So I got my use expressions up here. Let's make an extrude with that sketch in Y direction. Yes, that's an old one, 0, and that length should be a formula, and that value should be the counterweight width. Okay, and turn the direction around, yes, and okay. Then I need my channels up here, the crankpin channels. So go for a sketch. In this case I will put it there. So this should look something like this. Okay. Are these aligned? No, they're not, so make these two collinear, and that distance would be the crank pin channel width. So go for another formula. Crank pin channel width. Okay, let's I'm so used to other programs. You have to type, of course, crank pin channel width. Now it's okay. And that distance might be 5. Really 5. And that distance is 5 as well. Close that one. Now that distance should be 24, and this one should be 28. Close. Now let's align that line with the axis, collinear, and this one with that axis, collinear. Finish that sketch, make a revolve with that sketch. Around which axis? Around, in this case, the y-axis. Needs a point, so go for 0, 0, 0 and confirm and make it 360 degrees and make it a new body, so go for none. Okay, let's hide those sketches. Then the main channel is almost the same, so I could of course copy the revolve and the sketch. Copy and just Control V for paste and just confirm. What I have to do now is just change the values right here, and this one is of course wrong. This has to be not the crank pin channels width, but the, go for user defined expressions, the main channels width. So this should be the main channels width. Okay, and I have to change those two values. This one should be 42 and this one should be 38. Let's switch to the other mode without timestamp order. So this would be the counterweight. This one would be the crank pin channel, and this would be the main channel. Okay. Now I would need the, what it's called, the main bearing channel. So go for another sketch on that plane. And this might look something like this. Up, 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 and up. Okay. That distance might be 150. This distance 5. That distance 55. And this one 115. Now this should be 22. That should be 30. This should be 38. Close? No, not, yeah, close. And now align these two and those two. Finish that sketch. Make another revolve with that sketch. Go for the y-axis. Point is 0, 0, 0. And confirm. That distance is wrong, so this would be the main bearing channel. Main bearing channel, and change that one value, and this would be, I think I forgot this one. Yes, I did. So that distance should be 42, and close and finish that sketch. Hide the sketches. Okay, then I need the flange, so let's check if I did this with non-boolean. Yes, that's okay. Okay, of course I did, otherwise there would be not a new body. So I could hide those for the moment. One of the advantages of bodies, make a sketch right here. Okay, and this one looks something like this. Okay, this might be 25. This might be 15. And that distance could be 30. And that one could be 55. Now align these two. That should be collinear, and that should be collinear as well. Finish that sketch, make another revolve with that sketch, go again for the y-axis, the point is again 0, 0, 0, and confirm. And this should be the flange. No. Okay. So next I want to make copies of these bodies. So go for extract geometry. I want to have copies associative, so go for the counterweight, apply, then for the cranking channel, apply, then for the flange, apply, main bearing channel, apply, and for the main channel, apply. Cancel this out, so on top there should always be the copy, so hide those original solids and change the name, add a C, for copy, C, okay. Now I want to move the flange to the correct position, therefore I will need another expression. So go to Tools, Expressions, call this segment length, and this should be, of course, 5 times. No, not 5 times, it's just 2 times the counterweight width plus the main channel's width plus the crank pin channel's width. And this should be in this case 120. Yes, it is, and confirm. Now move the flange with menu, edit, move object. I want to move that flange copy. The vector should be the y-axis, and that should be a formula 5 times the segment length. And OK, and OK. Let's take a look. Yes, this looks good. Now move those channels to the correct position. The crank pin channel should be moved again a distance. The vector would be the same as before, and that distance should be the counterweight width. Okay. Confirm. And then it should be moved once more. It should be moved in the Z direction, and that value would not be a formula but just a value. So that should be 40, but therefore we will have to delete this one and add 40 right there. Okay, the object should be again the crank pin channel. Apply. Next would be the main bearing channel, and this should be moved along the Y direction, and that should be a formula. And this would be 2 times the counterweight width plus once the crank pin channel's width, and enter, and OK. So let me take a look. That seems, oh yeah, I took the wrong one, sorry. I'm kind of, this move should be not that, but this body. Okay. Now I want to pattern this one. So go to home, go to more pattern geometry. I want to pattern this body along the y-axis, of course. 2 instances, and the distance between those two should be, of course, formula, and that would be the crank pin journals width. No, yeah, I know. Crank pin journals width, and enter, and OK. But I have to add one counterweight length as well, so it's plus the counterweight width. Confirm and OK. Now it's on the correct position, and that's OK. Now let's unite those. And you should note there is another body right here. That's another body. So you got, that's the copy 2, that's the pattern copy. So I will add there sort of another, that's the patterned instance. Now I want to unite those. So this one to that one, this one and that one. Okay, and you should of course keep the target and keep the tool. Okay, so there should be a new body. That might be that one on the top, yes, and that's the segment. Now you could go for a copy of the segment, but that's not necessary. Now I want to pattern that segment. So go for more, go for pattern geometry, and I want to pattern that segment. The vector would be again the y-axis, and I need 5 instances, and the length or the distance between these should be the segment length, of course. So that should be the segment length. Okay. That's okay. Count and pitch, I got 5. Now the interesting thing with the pattern in NX is you can arrange those in different positions. That's quite interesting. So I could go there and go for clock, and if you change within pattern definition to user defined, you could even rotate them, and that's sort of crazy, but that's very nice. So I could go for an angle, and I could rotate this around the y-axis. Of course I need a point, that would be 0, 0, 0. And now I could use an angle, and that angle should be, let me check, that angle should be minus 144 degrees. And OK. And now I could do this for that instance. Just go there, clock. Again, go for user defined. Go for an angle. Again, that axis. Again, the 0, 0, 0 point. And that angle would be minus 216. Okay. Then the next one, again clock, again go for user defined, and go for an angle, vector, point. If I would have defined an axis, it would go even faster. And that angle should be minus 288. Okay. And the last one, again go for clock, go for user defined, go for angle, that's the vector, again the point 0, 0, 0, and that angle should be minus 72 degrees, and confirm, and I'm done. So if I now change one of these values, it should work. Let's try. Make this one 30. Very nice. Make this one, for example, 50. That one 50. Yeah, works. So that pattern feature in NX is very, very good. I'm not aware of any other pattern feature which could do things like this. So, hope you liked it. If you liked it, please give it a like or leave a comment. If you want to see more, please give it a like or leave a comment. Please subscribe to my YouTube channel. Please subscribe to my Facebook cat fan page and please like it over there. It would be very nice of you. Thanks for watching. See you to the next one. Bye bye.